All right, in your notes, what I need you guys to do is label them as arcs and central angles. We're going to talk about 3 different kinds of arcs. But first of all, we need to talk about arcs. What is an arc? Before we start talking about what kind of arcs there are. Arcs are, we're not talking about Noah's Ark. Arcs are portions of the rim of a circle. And I know that's not the technical definition, but that's what an arc is. They are portions of the rim or the perimeter of a circle. There are 3 different kinds of arcs. The first of them being what we call a semicircle. What is a semicircle?
Half.
It's a half of a circle. It's exactly half of a circle. A semicircle is half of a circle. And it's an arc, by the way. Half of a circle, it's an arc. But there are 2 other kinds of arcs. One of them is called a major arc. Say that again?
So this sounds like
Oh, major, yeah, okay. Major arcs. What is a major arc? If you had to guess, what do you think is true about a major arc?
a fourth of a circle.
Say that again?
A fourth of a circle?
A fourth of a circle? No.
It looks like a U.
Can you grab the door for me, please? Thank you. A major arc is an arc that has a degree measure of more than 180 degrees. Major arc is more than 180 degrees. So my next word is a minor arc.
So it's below 180 degrees?
Yes. So it is an arc that has a degree measure of less than 180 degrees. But I want you to put a little note next to major arcs. When you name a major arc must contain 3 points or 3 letters. In a minor arc, you only have to use 2 points or 2 letters. And I will tell you what I mean by that in just a second. So major arc, 3 points, minor arc, 2 points. Can I flip to a new page? Draw a circle. I want you to name that point A. Try to put your points in exactly the same spot that I'm putting mine. Let's call this circle O, by the way. We'll call this point B. I'm going to call this point C. And I may add a D later, but for now this is good. Now, notice I purposely put A and B directly across the circle from each other in hopes of creating, anybody want to guess what kind of an arc I'm creating when I put them exactly across from each other?
The one half.
What's it called when you have a half of a circle?
Semicircle.
Semicircle, yeah. That's what I'm trying to create. All right, so what I would like you guys to do is look at this picture and label for me a major arc. Label all the major arcs. Help me, all the major arcs. Major arcs in this picture, first of all, you have to name them with 3 letters. Because if you guys tell me that you are talking about arc BC, how do I know what BC you are talking about? Are you talking about the distance from here to here? Or are you talking about the distance from that B all the way around the circle back to point C there? So, if you just give me 2 letters, I know that you mean the one that will get you there in less than 180 degrees. But if you give me 3 letters, then I know that you are going to take the long way, more than 180 degrees. So I need a major arc. Give me a major arc. Go ahead, Omar.
AOC.
Say that again.
AOC.
Okay, that would be an angle. We're talking arcs. We're talking about around the outside of a circle. Go ahead, Kyle.
We do B-A-C.
B to A to C. If you start at B and then you go to A and then you end at C, that would be a major arc. Now, look what I do. BAC.
Couldn't you do a?
You gotta do an arc symbol on the top of it. If you just write BAC, I don't know what you're talking about. You put BAC with an arc symbol on the top of it, I know what you're talking about. Go ahead, Liz.
Couldn't you do a BC too?
A, B, C. So start here at A, go all the way over to B,
Mhm.
and end at C. Is that a major arc? Absolutely, yes. A to B to C is a major arc. What if you did CAB? Would CAB work?
Yeah.
Yeah, but CAB is the same thing as BAC. So don't write CAB. Do you understand what I'm saying? CAB is the same thing as the BAC, just written backwards. So don't use that one. Are there any other major arcs up there?
CB.
Could you go from C to B to A?
Yeah.
Well, why am I not going to list that?
Oh, because it's the same as ABC.
Yeah, because I already have CBA just in the opposite order. So I think that those are my only major arcs. Let's talk about minor arcs now. Minor arcs are arcs that are less than 180 degrees. And I think that we have more than just 2 options for this one.
AC. Is it
Give
AC?
me one. Go ahead, Brandon B.
AC.
AC. So if I go from A all the way down here to C, that is a minor arc. Minor arc AC still needs symbol. Notice it has 2 letters. Minor arcs have 2 letters. I need another one. Go ahead, Chelsea, give me one.
Okay, hold on. AB.
Okay, AB is not actually considered a minor arc
Why?
because it is a semicircle. It's 2 letters, yes, but it is exactly, if I start at A and I go over here to B, I've only done half of my way around a circle. That's equal to 180 degrees. A minor arc is less than 180 degrees. So try another one, Chelsea.
BC.
BC, very good. I think I just said a minute ago that we have more options for minor arc. I don't think we do. I think those are the only 2. So I was wrong when I said that. B to C is your other minor arc, and those are the only arcs that you have in this picture. So now semicircle, Chelsea. Where is the semicircle?
AB.
AB, very good. And this one, you can give me 2 letters, you can give me 3 letters. Either way, if you start at A and end at B, that is still talking about a semicircle. So a semicircle, you can use either 2 or 3 letters. So minor semicircle, A to B. By the way, could you say B to A?
Yeah.
Yep, same thing, but you don't need to say that because you already said A to B.
But wouldn't AC be the one too? Because isn't that halfway too?
Nope.
What's
So watch, if I connect A to C, that kind of divides it. It has to go through the center of the circle.
Oh,
That line has to go, yeah, there you go. It has to go right through the center of the circle.
Oh, now I get it. Okay, that's why it's not one.
All right. Let's say that in this picture, let's finish up our picture now. Draw that in. Let's say that I tell you that the measure That little m means measure. The measure of arc BC is equal to 30 degrees. This arc right here is 30 degrees. What then is the measure of arc AC? The measure of arc AC equals what? Sherilyn, what were you going to say?
60.
You were thinking 90 degrees. It's not, they don't add up to 90 degrees.
180.
So if B to C is 30 degrees, the rest of it has to make it equal 180 degrees, not 90 degrees, okay? So the measure of arc AC, that's from here to here, that's going to be 180 degrees minus 30 degrees, which is going to get you 150 degrees. All right, let's do one more. What about the measure of arc ABC? What is the measure of arc ABC? By the way, is it a major or a minor arc?
It's 180.
It's a major arc or a minor arc?
Major.
It is a major arc. How do you know immediately that it is a major arc?
Because it's a big.
Because it has 3 letters. Very good. So what is the measure of arc ABC?
180.
Should be 180 degrees plus another 30 degrees, which would get 210 degrees. So we have 180 plus 30 is equal to 210 degrees. Okay? 2 more words I want to show you guys. Can I flip pages? You good, Tyler? Draw a circle. Do I need to go back to the other page? You guys are. Put a dot in the middle. Label this point P. And draw Pac-Man. There it goes. This angle right here is what we call a central angle. Why do you think it's called a central angle? Well, it doesn't. We don't know for sure. It sure looks like it takes a little force, which maybe a little less than 4, but central. Central. Why is it called central?
It's in the center.
It is contained in the center of the circle. You see this point P? That's the center of the circle. And this angle is made so that the point of the angle, the vertex of the angle, is at the center of the circle. Are you with me there? A central angle has a vertex, in other words, the point at the center of the circle. As a vertex at the center of the circle. Now let's say that you knew that this central angle had a measure of 80 degrees. If it has a measure of 80 degrees, do you see, if I extend the sides of that angle and it intersects that circle, we have created an arc. Would you agree with that? We've created an arc, and this arc has exactly the same measure as its central angle. You need to commit that to memory and know that, because that's going to show up over and over and over again as we work through this unit. If the central angle is 80 degrees, the arc is 80 degrees. If you knew that this was 80, you could then assume that that central angle was also 80 degrees. So I'm going to make a note here that central angles and their intercepted intercepted is a fancy way of the arc that it creates, the angle creates at the same measure. Yes.
So it's only the same if it goes on past the circle.
If it goes where?
Like, if it goes on past the circle.
Well, I just extended the sides of that just so that I could show you that this was the arc that I'm talking about.
Alright, so it's always the same.
Yeah, so no, it doesn't have to go past the outside of the circle. This has to go to the circle, and it just I just wanted to show you how it created that little rim, that little arc around the outside of the circle, okay? All right, are we okay with this? Central angles and their arcs have exactly the same measure. I would like you to draw another picture. We're almost done, you guys. Draw another circle. Put a center in the middle. What do you want to call it?
Oh.
Okay.
Pickles.
P.
C.
Oh.
We call it P. That's normal for circles to have that as their. Alright, so that's P. And I want you to go ahead and draw in your diameter. Label one end of it A. Label the other end of it B. Let's label this part right here as C. Similar to what we did. Yep. And let's say that this angle right here is 45 degrees. That's the only thing that I'm going to give you. And I want you guys to figure out lots of other things about this. So the first thing I'm going to ask you is this. What is the measure, M means measure, of arc BC? Minor arc BC, 2 letters. So we're talking the short distance from B to C, not the long distance from B to C. It's 45 degrees because this central angle and its intercepted arc have exactly the same measure. So the measure of arc BC is 45 degrees.
So the AC is 135. I'm sorry.
What about the measure of arc AC then? Derek, 135, yes. The measure of arc AC is equal to 145 degrees. And you find that, what did you do, Derek? Very good. 180 minus 45 degrees would be equal to 135 degrees. So we now know that this is 45 degrees. We also know that this arc right here is 135 degrees. What about this? What about the measure of angle? See the angle symbol? What about the measure of angle APC?
135.
APC, that's this angle right here. It is a central angle, so it is exactly the same as its intercepted arc. So yes, it is exactly 135 degrees. All right, what about the measure? That's supposed to be an M. The measure of arc AB. A to B. Start at A, go to B. What is that? Called a semicircle. Has exactly 180 degrees in it. All right, what about this? The measure of arc ABC. So you start at A, you go all the way down to B, and then you keep going to C. This is 180 degrees as a semicircle. So we have 180 plus 45. 180 plus 45 degrees. Help me out. That is 225 degrees. One more question. What is the measure? Actually, I think I'm done, aren't I? I don't think I can come up with much more there. All right, I want to show you one more thing really, really quickly because I feel like this is the perfect opportunity to tell you because whenever I've done this in the past, I have not talked about this other kind of angle at this point, and students struggle with it later. So one more drawing. What I want you to do is draw yourself a central angle. I'm going to call this point P, I'm going to call this point A, and I'm going to call this point B. And I'm going to say that that angle in there, let's just say it is 92 degrees.
So the outer one is 92.
It is 92 degrees, yeah. So that means that the arc that it creates because the center, the vertex of the circle is the the vertex of the angle is the center of the circle, we know that arc AB is also 92 degrees. But there is another kind of angle that we can talk about, and I want to make sure I talk about it now while you guys are thinking about this stuff. Put your pencil at A, and draw a segment that goes not to the center of the circle, but goes to anywhere along the outside of the circle. And stop right there. And then I want you to take your pencil now and connect it to point B. Just like that. It does look weird. Yep. And it does not matter where you drew this, where you put this point. We'll call it point C. It doesn't matter if point C ended up here, or if point C ended up down here, or down here. If you started at A, went to the rim of the circle, and then back to point B, this always happens. This angle that you have created, please label it. It is an inscribed angle. Kind of like it's caught, trapped inside the circle, but the vertex, the corner of it, is not the center of the circle. It is on the outside of the circle, and there is a different relationship that exists between this arc AB and inscribed angle. Does anybody want to guess what that relationship is?
They're not.
They are not the same, but what are they? There is a relationship between them.
One's an after both angles.
Yeah, they are half. Whoever just said half. They are half. This angle right here is exactly half of its arc. So in this case, that inscribed angle is going to be 92 degrees divided by 2. So it is exactly 46 degrees. So inscribed angles, last sentence, you guys. Inscribed angles are half the measure of its inscribed. That's not what I meant to say. I used inscribed in the definition for inscribed. Of its intercepted. Arc. Inscribed angles are half the measure of its intercepted arc. And we will touch on this again later, but I wanted to mention it now while you're thinking about central angles.
Okay.
All right.